So welcome everybody once again to another interview here at Oddin Noticias. This week we have the absolute honor to be speaking with Dr. Peter Gruss, the president of the Okinawa Institute of Science and Technology and former president of the Max Planck Society for the Advancement of Science. Dr. Gruss, thank you so much for having us. It is a true honor to be able to speak with you today.
Well, it's an honor for me, Jose, and I'm looking forward to the interview.
The first question we would like to ask is really simple. How is a day in your life? How is a day in the life of Dr. Peter Gruss?
Well, my day is actually quite diverse, depending on the duties, and my duties circumscribe a real broad spectrum. In terms of professional duties, I have to discuss research with our scientists, I discuss education with our students, and I discuss technology transfer because our university has a spectrum that starts with the education and ends up actually with ideas and concepts that we can use in industry. But there's much more. I have, of course, managerial meetings because OIST is rapidly growing. My job is to double OIST in the next 4 or 5 years. So I'm discussing strategy with people from the outside world, with people from within OIST. And after all, we are paid by the Japanese public. So one of the key jobs is to bring the advantages that OIST can provide to the Japanese society and, let's say, the world community, to the politicians, to the industrialists. So I'm talking with ministers, occasionally with prime ministers, in order to transmit what can science do for society.
Let's speak a little bit more about your career. When did you discover your passion for science, Dr. Gruss? Was it at a young age or did it come later in life?
No, I think, frankly, I did have always a knack for the sciences. I was not so interested in humanities for a very simple reason. Not that I disliked them, but what I did not enjoy was that the outcome of discussions in humanities could be manifold and all could be correct. While in science is fact-based. So I enjoyed having facts, and once you have facts, there's very little discussion. You can interpret the facts differently, but the fact is a fact. So that's why I very much liked and enjoyed the sciences, and that happened actually in high school. And I was subsequently very lucky that I picked a field that actually exploded while I was in it, and I was at the very beginning of what's called today molecular biology, which didn't exist when I was young. So there was a field where I could help actually shape it to some extent, but it's also a field that has delivered a huge impact on the entirety of biology and medicine.
And now let's focus on your research, Dr. Gruss. Your work has focused on gene regulation processes. Could you please explain to our audience what these processes are about?
Absolutely. It's a pleasure. Now, when you look at our body, you and I, we look different. We have about at least 3 times 10 to the 13 cells in our body. Wow. So that is like 30 trillion cells that make up our body. All are different cells, and they can roughly subdivide it into 200 distinct cell types. So cells that make up an eye, cells that make up brains, neurons, cells that make up a limb, like our extremities. So somehow, someone or something has to govern that to make that complicated structure appear during embryogenesis. And that was exactly my research when I started to do research in gene transcription, in gene regulation. Now, if you look up, every cell has about 2 meters worth of DNA. Oh. On the DNA, we have our genes, and every cell has a different jet of genes being active. Every cell has the same type of DNA, but different genes. You can maybe compare it to like a conductor. Okay. You know, there are compositions, they are very different, and based on the compositions, you have different instruments. And there has to be a conductor who makes sure that all the instruments play the right tune. So that's what I was discussing. That's what I was working on, to have the conductor genes, if you wish, for for insulin-producing cells, for heart, for kidney. This was the essence of my research when I was running my own laboratory.
And now, Dr. Gruss, you have also been able to produce insulin using stem cells, which seems to be a truly impressive achievement for mankind. However, I would like to ask, how can you create insulin with this process in particular, and how can humanity benefit out of it?
Well, this was a part of my research because I was exploring genes that can trigger the differentiation or development of specific organs, like, for example, the eye, or like insulin-producing genes in the pancreas. Okay. And we discovered more than 20 years ago, believe it or not, a gene that can direct the differentiation of stem cells into insulin-producing cells. And afterwards, that really triggered research. I think hundreds of papers have followed this and have now been able to come up with genes that help us stimulate the differentiation into insulin-producing cells. And I'm absolutely positive that this research will ultimately result in producing insulin cells that can replace either dead cells that produce insulin, or you can implant cells into the body of diabetics that then can produce insulin in a more natural way.
And did you ever think your research would generate this impact on humanity?
I don't think that was the outset. That cannot be the outset. This would be a hubris if you would start with that. But obviously you need to be open-minded. So every research, of course, delivers a new fact, a new element, something new for the world. That's what good research is all about, something that no one has seen before. And when you see that, you are the first who can make an association with what could that actually mean. And of course, being a biologist, it was a medical relevance that I was thinking of.
And now, let's speak about nowadays, Dr. Gruss, because you're currently the president of the Okinawa Institute for Science and Technology. So tell us a little bit more about this. What led you to this position, Dr. Gruss?
Well, like you said at the beginning in your introduction, I have been a science manager for quite some time now, when I decided in 2002 to become the president, or to accept the proposal that I am the president of the Max Planck Society. Now, Max Planck Society is a world-renowned research institution with 35 Nobel Prize laureates that have been working in the Max Planck Society. And I was learning also, not only managing, what makes a top research institute? What are the elements that are required to make a top research institute? So with this background, I was offered a position at OIST here in Okinawa, in an institute that has all the same ingredients: top quality, internationality, actually a level of internationality I've never seen before. Wow. We have 65% of our professors and staff are non-Japanese. 80% of our graduate students are non-Japanese. And that leads to an atmosphere that is not just international, it's also creative. And you may wonder what makes it. Why is that? Well, because we are autonomous, we are free. The Japanese government gives us money, and with that money we can deliver competitive funding for research that I call is long-term, creative, and stable. So high trust funding is an integral element of OIST and allows us to attract top talent from all around the world.
And what would you say differentiates the Okinawa Institute for Science and Technology from any other institution in the world? Is it this independence, or what is it?
I think it's this. It's one, that this is an experiment that is nowhere in the world I can see, a new startup that has managed, by the way, within the last 5 years to already produce, if you consider our small size, to produce the highest number of top research papers in Japan.
Wow.
And for me, the integral elements are competitive funding that is given to our young people for 5+ years, so that they don't need, if they don't want to, write grants. They can write grants, but they don't need to because they get stable funding. And of course, if you want to attract the best minds around the world, you have to also give competitive salaries. So given that we have a new institute with the top equipment, top facilities, I think that makes up something unique around the globe.
Well, thank you so much for having us, Dr. Gruss. And before we go, I would really like to ask, what would you recommend for anyone watching this interview that may be interested in pursuing a career in science?
Well, this is also sort of part of why I went into science. It's the wonderful profession. Okay. It's the best profession in the world. Why? Because you can make up a mental image of the world. You are curiosity driven. You have to be curious. You have to think about ways, and you have concepts, whether in physics, in chemistry, in biology, but you can think ahead and you can test your ideas experimentally or theoretically. So anytime then you come up with a new result, this result is a little bit improving the world. It allows a little bit to make the world a better place to live in. That's why it's the best job in the world.
Well, Dr. Gruss, thank you so much for having us. It has been a true honor being able to speak with you today.
Thank you so much, Jose, and all the best to you. Thank you.